Hello, my name is Brittany and this is my week 2 Teach the Doc. So we'll get right into it. For problem 1, give the atomic numbers for each of the following elements using a periodic table. C is carbon, that is atomic number 6. Iron is 26, as you can see here. And then for Br, that's bromine, and that is number 35 on the periodic table. The second part here, mass number is equal to the number of protons plus neutrons, and we'll use that as we move down into this. So we're looking at isotopes now, and we're given different parts of this and then filling in the blanks. We know that your number of protons and your atomic number are always the same. Your mass is always going to be your protons plus your neutrons, and then your charge is your protons versus your electrons, and whether it's positive or negative. So for this first symbol here, we have 17 protons, and then we have the mass number already given to us as well. So we can take 35 minus 17 and come up with our neutrons, since protons plus neutrons equal your mass number. And then we did not, our protons and electrons are the same. There's no charge to this. Here for the second one, we were given, this is the only information we were given. Okay, so we have 30 protons, like here in the bottom, and then 64 would be our mass number. Our charge is 2 plus, so we know that we have 2 less. We have 2 more protons than we do electrons, so we know we have 2 less electrons than protons. And then here on this one, we had to fill out the formula based on, or the equation based on, or the symbol, sorry, based on all the information we were given. So we know that the mass number was 65, so we'd put that up here in the corner. We know that the neutrons, we had 34, so then we can take the mass number minus 34 to figure out what our protons are. And then we were given the 3 plus charge, so we know that there are going to be 3 less protons or electrons than there are protons. Same thing, we had to figure out the symbol for this one, so we knew that there were 34 protons and 45 neutrons, 36 electrons, and the mass number was 79. So 34, we knew that that was going to be selenium on the periodic table. And then our neutrons, this plus this would equal our mass number. Our mass number goes here, protons go here. And then our charge was 2 minus because there were 2 more electrons than there were protons. Sorry, that was kind of sloppy. Moving on. Okay, so we're going to calculate the atomic mass for lithium. We can see here that the isotope lithium-7 is a lot more frequently occurring than 6. So we already know that the number is going to be closer to the mass of lithium-7 than it is to 6. But our formula will do 6.0151 times this percentage. So we would move our decimal over to 0.0759 plus, same thing here, 7.0160 times, move our decimal over, 0.9241, add those up, and that ends up to be 6.94 atomic mass units. Moving on to ionic compounds. For A here, we are going to be naming ionic compounds. So that's the name of your cation plus your anion. It ends in "ide." So we wrote down our ionic compounds plus our formulas. So we know that these are always metals and nonmetals. So there's always something from over here and then something from over here. So some examples I have are lithium oxide. So lithium right here, oops, I am touching things. Lithium right here is going to be a, write that down on this. Okay, I'm back. Lithium is a +1 charge. Oxide is a 2 minus, so we would need 2 lithiums to add up to our oxygen. So lithium oxide, and then we'll follow that same rule for all the rest. Potassium nitride, K3N, sodium chloride, NaCl, aluminum oxide, Al2O3, potassium iodide, Ki, since that's just 1 potassium here, and then the I over here, this is a halogen, so it's a 2 or 1 minus charge. Let's see, we'll keep going. Sodium fluoride is NaF, lithium fluoride LiF, sodium nitride Na3N, lithium nitride Li3N, and potassium chloride KCl. So those will all follow the same rule. And then we have for B, we are going to name binary, molecular, or covalent compounds. So that's when your prefix is the name of your first element plus the name of your second element ending in "ide." And these are always a nonmetal plus a nonmetal, so they are covalent. For examples here, we have N2O3 or dinitrogen trioxide, di for the 2, tri for the 3. And then you always add ide at the end. P4S10, so phosphorus, and then you'll put the tetra there before for the 4, and then deca for 10, sulfide. You change your sulfur to your ide. CF4, carbon, doesn't have anything because it's just a single carbon, and you don't apply the prefixes to the first element. And then tetra for 4, fluoride, PCl5, phosphorus, penta for 5, chloride, Cl2O7, so there's 2 dichlorine, hept, and that would be hepta for 7, but since it's ending in oxide, we just do heptoxide. P4O, tetraphosphorus, hexoxide, CO, so there's just one of each, carbon monoxide, because the oxygen, there's only one, but since it's the second word, you do apply the mono for this one. SF6, sulfur hexafluoride, and that hexa is for the 6. N2O5, di2, nitrogen, pent, and that's for the 5, pentoxide. And then NO2, nitrogen di, there's 2 oxygen, dioxide. And then moving on to C here. Did I talk about that in the last one? I don't remember which one I read off last time. This is naming binary acids. So we add hydro to the beginning, and then we list the nonmetal ending in ic, and then add acid at the end. So here's some binary acids. These are hydrogen ions bonded to a negative ion. So there's always a hydrogen, and then you break apart the second to name it. So HF, that's hydrofluoric acid. HCl, hydrochloric acid. HBr, hydrobromic acid. HI, oh, this one's hard to say, hydroiodic acid. H2S, hydrosulfuric acid. H3P, hydrophosphoric acid. H2SE, hydroselenic acid. H2TE, hydrotelluric acid. HAT, hydrostatic acid, and H2O, hydroxic acid or water. And then moving down to our oxyacids, these ones we are naming our oxyanions. So these, if the anion ends in 8, we'll change the ending to ic and then add acid. And then if the anion ends in ite, we'll change it to us and add acid at the end. So I've got my polyatomics here next to me. So HNO3, that is our NO3. Let's see if we can find it over here. That is nitrate. So it ends in 8, NO3. So we'll change it to nitric acid. H2CO3, carbonic acid. So we'll look over here for our CO3. And then since there's 2 hydrogens, we would need 2 minus of this to create carbonate. So that's why it's H2CO3 and not just H. And then following that same pattern, H2SO4 is sulfuric acid. It came from sulfate. PO4, and then that would have a 3 minus. I'll show you. PO4, 3 minus, that's phosphate. Would end up being H3PO4, phosphoric acid. And then this is a long one. HC2H3O2, acetic acid. That comes from acetate. So I'll show you C2H3O2 with a minus charge. So we only have a 1 hydrogen to go with that. And then here's our 5 examples of our anions ending in "ite." So we'll change the end of the ion to "us," and then we'll add acid at the end. So nitrite, HNO2, that would be NO2 minus charge to balance out this H, nitrous acid, HCrO2, chromous acid, that comes from chromite. H2SO3, if we break that up, that'll be a hydrogen and a sulfite, so that'll turn into sulfurous acid. HClO2, this ClO2 is a chlorite, so chlorous acid, and then H3PO3 is our last one. The PO3 would have a 3 minus charge, that's why we have 3 hydrogens, and I'll show you that. Let's see. Here is our phosphite, the 3 minus, PO3, 3 minus charge, H3PO3, phosphite turns into phosphorus acid.